let's try another example. So these are two linear equations with a less than sign in between. So this question is asking, when is this equation less than this equation? Or when specifically are these y values less than these y values? So now that we've done equations just like this, try solving it on your own and come back to the video once you think you've got it. So if you're back at the video, you're here to check if you've got the final answer. So we're left with an answer of 7 over 5 is less than x. Another way to write that is just putting the x first and a greater than sign. X is greater than 7 over 5. So just a quick recap. The first thing that I did is I wanted to get rid of this fraction, so I multiplied both sides of the equation by 3. So that those 3's canceled out here. And on the right side we have 3 times 2x minus 3. Expanded that out. Collected like terms. I brought the x onto this side rather than the 6 onto the other side, just because I didn't want to deal with the negative in front of the x, and isolated for x, and here we have it. So if we were to write this on a number line, we'd have 7 over 5. 2 is greater than 7 over 5, 1 is less than 7 over 5. The solution does not include 7 over 5, so I'm going to put an open dot that way, and x can be anything that's greater than that. Now let's take a look at this example. This is quite different than what we've seen before because there's two inequality signs. So this is a double inequality. So to figure out really what this is asking, let's simplify the inside as much as possible so that we can better understand what this is asking. So first try to simplify what's in the middle and then come back to the video. So once we simplify this linear expression here, we just get 4x plus 10. So this question is asking, when is 4x plus 10, when are the y values of 4x plus 10 going to be equal to or in between 30 and 46? So when will the function 4x plus 10 be equal to or in between 30 and 46? So let's take a look what this looks like algebraically. Sorry, I didn't mean algebraically. Let's take a look at what it looks like graphically. So let's start off with the line y equals 4x plus 10. So let's also we'll start with the second part of the inequality of when is it less than 46? Well, if this is 50, 46 is just about here. So let's figure out at what x value it's going to be less than 46 or equal to 46. So here's the x value in which the function is equal to 46. So everything less than 9 then, the function is going to be less than 46. So if this was our only inequality, that would be our solution when x is less than or equal to 9. But that's not the only part that we're looking for. We also need to figure out when it's going to be, let's just get rid of this blue guy. There we go. So when is the function going to be greater than 30, or when is 30 going to be less than that function? So where's 30? 46 was up here. 30 should be somewhere around here, somewhere around this line here. So let's see what it looks like here. Okay, so here is where the function is exactly equal to 30. It's whenever x is equal to 5, and it's going to be greater than 30 when x is greater than 5. So we have these two answers for x. X can be greater than 5. And then also, if we add in this restriction here, where the function has to be less than 46, we have x is bound between 2 points. So let's click on these points of intersection again. So where the blue overlaps the red is where this statement is true, where the function both has to be greater than 30 and less than 46. So wherever these two overlap, the red and the blue, you can see it's making this like sort of darkish reddish bluish color. That's where the solution must be. So in between 5 and 9, that is the only time when the function is greater than 30 but less than 46, just in this little sliver right here. So whatever solution we should get algebraically should match this, what we found graphically, that x should be between 5 and 9. So let's check it algebraically now. So to solve a double inequality, all we need to do is we can either work on both sides separately or both sides at the same time. It's going to be easier to just work on them both at the same time. But for example, if we need to move this plus 10 and we're going to move it onto the other side, we've got two other sides. So we've got to subtract 10 from both sides. So that's what we're going to start off doing. Let's get rid of this 10. Our whole goal is to get x by itself. So we've got to do it to both sides. So we are going to have 20 is less than or equal to 4x is less than or equal to 36. And now we're ready to divide by 4. We're going to divide by 4 on both sides here. We don't need to change the sign because we're dividing by a positive number. And we have 5 is less than or equal to x is less than or equal to 9, which is exactly what we proved graphically. If we were to put it on a number line, our solution would be between 5 and 9. We would have closed dots on 5 and 9, and the solution could be anywhere in between these two. So let's take a look at this last example. It says some volunteers are making long-distance phone calls to raise money for a charity. The calls are billed at a rate of 50 cents for the first 3 minutes and 10 cents a minute for each additional minute or part thereof. If each call cannot cost more than $2, how long can each volunteer talk to a prospective donor? So there's going to be a range here. There's not just one answer. So it doesn't say how many minutes would they have to talk so that it was exactly 2. It's just that it has to be 2 or less. So let's figure out what this function actually looks like. So this is actually a piecewise function. It's going to be broken up into more than one function. So our cost function that we can say is a function of minutes. So cost is a function of minutes. It's going to equal 2 different things depending on the time. It could just equal exactly 50 cents, and that's if the minutes are less than 3 or equal to 3, because anything over 3 minutes costs additional money. But if we're 3 minutes or less, it just costs 50 cents. So we can't have negative minutes. So this is only going to be true when 0 is less than the minutes or is less than equal to 3. So if the minutes that we spend talking are between 0 and 3. Of course, we can't be equal to 0, in which case the call wouldn't exist. You can't make a call for 0 minutes. And the call could be equal to 3 and it still costs 50 cents. Let's just define our variables quickly before we do that. Let's say the minutes is equal to, m is equal to the minutes of talk. And let's call c our cost, total cost, as a function of minutes. So let's keep going defining this function. So after 3 minutes is when the function changes, just from this flat line at 50 cents or 0.50. Then it's going to go up to a charge of 50 cents. So let's start off with the 50 cents. But then they're going to charge us for 10 cents for every minute over 30. So we're going to add 10 cents for every minute over, minute over 3 minutes. So how can we write that? Well, we can take the number of minutes and subtract 3. So that's why we really need to define this function in 2 ways, because if that m value is less than 3, this is going to become a negative number, and this function is just not true. So this is only defined for all minutes that are, or m's that are greater than 3. So that's what the second value of our function can be. So it would be 50 cents plus 10 cents for every minute that's over the 3-minute mark, or every part minute. So the question was just asking, when is this going to be, it cannot be more than 2. So it has to be less than or equal to 2. So how many minutes can they talk? Well, in this part of the function, this is never going to be greater than $2. So we don't have to worry about searching that. We know when the minutes are $3 or less, it's not going to cost $2. So, but we have to take a look at this guy. We need to make sure that this is set to be less than or equal to $2. So I'm going to write this part of the function. So 0.50 plus 0.10 times m minus 3 has to be less than or equal to $2. So maybe you got to this on your own without writing it out like this, and that's fine. But this is good practice for understanding piecewise functions, which are functions that we piece together to make one giant function. So this is not the only function that's explained in this scenario. We also have this guy right over here. So anyway, so this pattern has to be less than or equal to $2. So let's just solve for it. So first thing I'm going to do is I'm going to expand this guy here. And I have 0.50 plus 0.10 m minus 0.30 is less than or equal to 2. I'm going to isolate for m and collect like terms as we go. So we have 0.50 minus 0.30 right over here. So I'm just going to subtract those two. So we have 0.10 m plus 0.2 is less than or equal to 2. I'm going to bring that 0.2 onto the other side. So we have 0.10 m is less than or equal to 1.8, sorry, 1.8. And then we're going to divide that by 0.10. So divide by 0.10, divide by 0.10. And we get that m has to be less than or equal to 18 minutes. So that means each call cannot exceed 18 minutes, and we're done.